Today we're going to take all of the different function transformations we've talked about in the last couple of days, and we're going to put them all together today. So over on the left, I've listed out every single kind of transformation that we currently know about. And in red, I'm going to go through and list what we have to do to the function to make that change happen. So for example, if we shift up or down, we have our function, and we have to add something to it or subtract something to it. I'm going to use k for just any number. That's just my favorite letter for that. Notice I also used a plus or minus, which means it could be adding or it could be subtracting. Similarly, if we want to shift left or right, we add or subtract directly from the x value. So it looks like that. Notice for up and down, it's in or outside of the parentheses. And here, it's inside the parentheses. And you'll recall that when it's to the left, we add, and when it's to the right, we subtract. Keep that straight. It's a little bit counterintuitive. Now, when it comes to the reflections, we have two different kinds that we think about: a vertical flip over the y-axis. Oops, I did an extra little thing there. Which, when you do that, it's going to look like f to the negative x. The negative is inside the parentheses. Or the horizontal flip across the x-axis, which puts the negative out in front of our axes. Lastly, we can talk about dilation. We don't use the word dilation very often, but it is a word that it comes up occasionally. The way that we dilate something is to take a number, for example, k, and multiply it to a function. In a linear function, that looks like a different slope. In exponentials, it looks like we have a different a value, the number out in front. If k is bigger than 1, it's going to be a stretch. If k is less than 1, it's going to be a compress. Now, there is something I do want to remind us of. If, for example, k was a negative number, for example, -4, we have a negative number, which looks like it's smaller than 1. However, the negative is actually going to be a horizontal flip. So we're going to flip across the x-axis, and then we do our dilation with the 4. So for this particular function, we'd flip across the x-axis. And then we would stretch by a factor of 4. That's just an important thing to keep in mind. Even though -4 looks like it's smaller than 1, if you remember that we've got to take the negative into account first, then we have a clearer picture of what's going on. All right, now let's go look at the parent functions over here on the right. Today we are going to be given the steps, and we have to talk about what changes we would do to the function to make those steps happen. All right, so for example, we've got f of x is equal to x. X is generally the parent function for any kind of linear function. It wants us to move it up to, have a vertical flip, and stretch by a factor of 3. First things first, let's talk about the up to. How do we move a function up or down? Well, we add. So in this case, we would simply add 2 to the end. You'll notice I gave it a bit of space. When I'm writing these out, I tend to space these out more than I would on other occasions when I'm writing things out. Next, we want to go ahead and do our vertical flip. A vertical flip is accomplished by putting a negative x in parentheses. Now, it isn't necessarily the most important thing in a linear function to make sure that that it's inside the parentheses, but it would make a big difference in an exponential function, so we'll practice here. And the last thing we've got to do is stretch by a factor of 3. So that means we're going to multiply the entire function by 3. Giving us 3 times negative x plus 2. we simply add the f of x, and there is our answer. We don't need to simplify any further. Oops, that's a bad box. That would work for the answer to this equation. We'll try another example. We have a parent function, f of x is equal to 2 to the x power. This is an exponential function. I'm noticing its growth, a growth pattern. And there we go. We want to move it to the right 3, have a horizontal flip, and move it down 1. So, first, let's move it to the right 3. To move something to the right, we've got to include it as part of the exponent. And since we want it to go to the right, we've got to subtract. Because when it's to the right, we subtract. So let's subtract 3 from the exponent. Now we want to flip it across the horizontal flip, or the x-axis, which means we put a negative out in front. If this were a vertical flip, we would have to make the x in the exponent negative, but since it's just a horizontal flip, we put the negative out front. And we want it to move down 1, so we go ahead and subtract 1. Let's go ahead and try it the other way. F of x is equal to x is our parent function again, and we're given f of x equals 1/2 x minus 4. Let's describe the changes here. Well, the first thing I notice is we have a minus 4. How do we move something? What's that going to do? It's going to move it down 4. That's a shift. All right, the next thing I'm noticing is we have a 1/2 here. That's one of the things that's different. 1/2 is a compression, so that's going to compress by a factor of 1/2. All right, we have another example with an exponential this time. So let's go ahead and talk about that one. We start with 5 to the x. We move to negative 5 to the x minus 1 in the exponent, plus 3. So I notice 3 changes. First, I notice that we have a negative out front. That's going to give it a horizontal flip. If you wrote something like flip over the x-axis, that would also be correct. Totally fine. Now we notice that we have a minus 1 here. That's going to shift it to the right. And we have a plus 3, which is going to shift up 3 units. Now I made a slight mistake on our middle point here, because I said shift to the right, but I didn't specify the amount of steps I need to take. So that should actually be shift to the right 1 unit. Make sure we specify that. Now I'm going to go ahead and take a second and just draw out a quick piecewise function. And let's talk about how we can shift those as well. So we'll just draw in our function really quick. I'm picking kind of points at random. Let's connect those dots. So when it comes to a piecewise function, we can do everything we do to all of the other ones, but instead of making you write it out in the formula, I'm just going to have you draw it. So let's go ahead, let's pick some things that we could do to it. Let's move it up to the left, move to the left 1, and let's compress. So we have 3 different things happening here, and I think it's hard when you have things like this to try to do everything at the same time. So I would probably start with these 2 steps together. I think you can move them together, and then we'll compress here in a second. So let's move up 2 and to the left 1. So there's our new point. Up 2, over 1, up 2, over 1 up to over 1. We can connect those dots. Now from here, we need to compress it by a factor of 1/2. So how I would think about doing this is remember that every compression we do is in the vertical direction. So we're going to take whatever y value we have, and we're going to cut that in half. So here, this point's at 0. 1/2 of 0 is 0. But this point right here is at 3. So we're going to cut that in half. That's going to give us a point right there in between. That's like 1.5 right about there. We'll do the same thing for the next point, and this one's 1, 2, 3, 4, 5. That's going to be like right about there. You can connect those dots. And our answer in red is our final answer. Let me know if you have additional questions.